everyone. This is Lori behind the camera. We are live here in Scienceport, which is part of the STEM lab at the Children's Museum of Indianapolis. And here today with me, I also have Becca behind the camera. She's going to be on Snapchat, so keep an eye on her there. And we have our slime guru and science educator, Don. Hi, Don.
Hi, Lori. How's it going?
Good.
Hello, everybody. I'd also like to introduce my lab assistant for today, Hans. If you could please come introduce yourself. Hans is going to be helping me out getting new supplies, because what we're going to be doing today, because slime is pretty cool, is we're going to be making 5 different slime recipes, right? And so I'm going to need more than just these ingredients and these supplies that I have right here. So if you want to make slime, you are always going to need a bowl to mix it in and some kind of spoon. You're always going to need some kind of glue. We'll experiment with that in a little bit. And then you'll need some other stuff, something called a cross-linking agent. Now that may sound a little complicated. Let me break it down before we even get started working on the slime. I want to talk a little bit of science so you know what's going on here. When you are making slime, you are always performing a sort of chemical reaction. That is taking one substance and turning it into something slightly different, right? Everything in the entire universe, everything, is made of itty-bitty teeny little pieces called atoms. And those atoms can be rearranged to make glue and, in this case, baking soda and contact solution form into slime. Atoms can be rearranged by setting a campfire. You're taking the atoms inside the wood and turning them into brand new things that they weren't before. That's what we call a chemical change. And slime making is a specific kind of chemical change called polymerization or cross-linking. See, glue, like this stuff right here, which is going to be our first ingredient in any good slime, is made of a bunch of tiny little pieces, all separated out from each other, called monomers. It comes from Greek. Mono means one, mer means part, so we've got all these tiny little single parts floating around inside our Elmer's glue. What we want to do is figure out a way to link those monomers together into a polymer. Poly means many, so we have many parts linked together. That is where we get our slime from. There are lots of different kinds of polymers out there. Plastic is a polymer, rubber is a polymer. Technically, your DNA is a type of polymer. It just means lots of smaller pieces are connected together into one longer piece. But it takes a chemical change to get from these monomers right here to some nice slime. For that, we have to take those monomers and cross-link them into a polymer. And for that, we need, like I said before, a cross-linking agent. For our first slime recipe, our cross-linking agent is going to be some baking soda, and like I said before, some contact solution. But before we do that, we want to get some color to our slime. So I'm going to make my first batch of slime red. Whole bottle of Elmer's glue, no more than 3 or 4 drops of food coloring, because you are going to be playing with this. And the more food coloring we have, the better chance it's going to stain things that you touch with it, like your hands, or your clothes, or your couch, or your dog. So try to just put a few drops in there. After you put a few drops of food coloring in there, 1/2 tablespoon of baking soda. This is going to be the only thing I'm going to measure out specifically for you guys, okay? Because half the fun of slime making is in experimenting with your ingredients to see what kind of slime you get, what consistency changes you can make by adding different amounts of things. So 1/2 tablespoon of baking soda and food coloring, and then mix it up in your mixing bowl. We're not doing any chemical changes yet. Right now, we're just adding some color. This is what we call a mixture or a solution. We have a bunch of different chemicals in here all together, but they're just mixed. They haven't recombined and formed anything new. It's a physical change instead of a chemical reaction. All right, we got our baking soda, we got our food coloring, nice pink slime, and see it? Got it? All right. Now we start adding our contact solution. I like to add a little bit and then stir it. Add a little bit and then stir it. So I'm going to do my first squeeze by myself. I'm going to start stirring, and then I'm going to ask Hans to come over here and squeeze in a couple of more squirts whenever I ask, right? You ready, Hans? Okay? Here we go. A little bit, eyeball it. Now we're going to start cross-linking. I'm going to come around to the front of my table here so you guys can see how Oh, look at that. Suddenly, it's a very different texture from what it was before. Now, we still have plenty of glue in there, which means we haven't added quite enough of that solution. So, Hans, you could squirt a little bit in there, please. Thank you. That's good. The nice thing about using contact solution as your cross-linker is, if you use a little bit too much, your slime may be a little tougher than you like, but, however, it won't get mixed in with your slime and make it super-duper runny. It'll just kind of run through the bowl, and you'll have a bunch of extra solution in there. So here we go. Let's see. See how sticky it is? That means there's still glue in there that hasn't been cross-linked. So a little bit more, Hands, please. Thank you kindly. All right. What we want when we're doing contact solution and glue slime is to mix it and mix it and mix it until it starts to come together and sticks on your mixing spoon, almost like, I don't know, a cake pop or something, right? So you can just kind of go like that, and oh look, it slid right off the plastic. Now we have slime that's a little bit sticky, but that's okay. There we go. This is plain old vanilla slime. Glue, baking soda, and contact lens solution. This is all that we have used. Now, if you want to jazz up your plain old vanilla slime a little bit, you can change up the kind of glue you're using. I made an early batch of this earlier because it's the exact same process. There's no point in me repeating it again. I have used glitter glue instead of white glue and made some, sorry I'm shaking your table.
That's okay, we forgive you.
Made some glittery slime right here. Only difference, same ingredients, except I used a bottle of Elmer's glitter glue instead of plain Elmer's white glue. That's it. Mix it up the same way with the same baking soda and the same contact lens solution. Now, we're going to change things up a little bit. What we are going to do at this point is change the cross-linking solution that we are using. Hans, could you please bring me some glue and some liquid laundry starch? We're going to set these aside for now. Liquid laundry starch works to do the same thing as your contact lens solution and your baking soda, but it's only a single ingredient. I prefer it because you don't have to add two things in. You just kind of eyeball the starch. You don't have to measure it all. But it's up to you which kind you like, because the slime will turn out a tiny little bit different depending on which cross-linking solution you use. The other plus of this stuff here is it smells nice. It's just a nice little fragrance for your slime. So here we go. We are going to, oh wait, that's my empty one. Full bottle of glue. Here we go. Anybody have any suggestions for the color that we should make this slime?
Blue.
Blue? Blue slime. All right, we can do that. Some blue Starch slime. Remember, you can do this one with glitter slime too if you want. It's totally okay. I'm going to do the same thing. You're just going to use glitter glue instead of white glue. Okay, there we go. Trash. And blue slime, we say. Now, ladies and gentlemen, I want you to remember something about slime while we are mixing this up. I'm doing this kind of in the style of a cooking show, but slime is not food, okay? It's non-toxic, technically, right? But there's a big difference between non-toxic and edible. So just because it won't necessarily drive you to the hospital doesn't mean you should put it in your mouth. So never, ever, ever eat slime. Play with slime. Throw it at the wall. I mean, that's probably not a good idea. You might stain the wall. Don't eat it. Don't feed it to your little brother or sister. Don't try to get your parents to make it into dinner. Don't feed it to your dog. Slime is not food. Are we understood? Are we clear? Okay, good. All right. So, we got a blue mixture of glue and food coloring. Now we're going to add in our new cross-linking agent. I'm sorry. I'm just getting the slime batter everywhere. See, this is why we have paper towels. We're going to add a little bit of that laundry starch. You'll see here, it's got a thicker consistency than our eyeglass solution or contact lens solution, but it is already beginning to cross-link those monomers, cause that chemical change to occur, and set up our slime. There we go. While I'm working on this, Hans, would you mind wiping up the floor, please? Thank you. I will. Okay. And now, it's still kind of running. We're not fully cross-linked. We can see it's a slightly different consistency because in addition to cross-linking the monomers, your cross-linking solution also becomes part of your slime. So when you use starch that has a slightly different consistency than your baking soda and your contact lens solution, you're going to get slime with a slightly different consistency. At the end of the day, we still want it to be nice and gooey and slimy, so we just keep adding little bits of our cross-linker, little bits of our starch, until we get a nice good slime. Let's see, how does that feel? A little bit more.
It's getting slimy.
I know.
Getting slimy up
Maybe
here.
too slimy. Who am I kidding? There's no such thing as too slimy. All right, here we go. Tiny little bit more. Let's see what happens. This is all part of the experimentation of slime making. There we go. Now it's really starting to come together. White glue, laundry starch, food coloring. Hands, can I get a little bit more of my starch here? Just, can you see? Can you see the slime? All right, get it in there. Pour it in. That's good. Perfect. All right. Oh, there we go. We're swimming in a little bit of starch. That's okay. It is totally okay, because here's what you can do. If you added a little bit too much to your cross-linker, you just pull your slime out of your bowl and then set it on a paper towel to dry. There we go. It's dripping off, but it is nice and very excellently slimy right here. Now, whether you use starch or baking soda and contact lens solution as your cross-linker is totally up to you. Like I said, I prefer the starch because it's a single ingredient instead of two. But you may like the consistency of the other kind of slime better. You may not have any starch on hand. Sorry. Here we go. Okay, next slime. We are going to add in an ingredient that does not change the underlying chemical reaction of our slime, but drastically alters the consistency of our slime. Hands, could I get glue and a bowl? And could I get a mixing spoon? Oh, and shaving cream. You hands totally anticipated me. Wonderful. Hands knows exactly what we're doing. Hands, did you get a manicure yesterday? Oh, nice. All right, cool. I like it. Okay, here we go. Do some glue. What color should we make this slime? We did, what did we do already? We did red. We did blue.
Green.
Green. Green slime. Classic.
Classic.
Classic slime. Trust me, this isn't any more exciting for me than it is for you. But it's got to be done. Okay. Glue. Green food coloring. 3 nice fat drops. Regular shaving cream. Okay? You see the shaving cream? Not gel, not the fancy smelling gel. I actually had to look at a different part of the shaving cream aisle to even find this, because everyone likes the gel these days. But we just want regular foam like this, right? That's all we want. I'm going to come up close so you can see. I'm going to add a lot of this foam. There we go. And just like our previous slime recipes, mix it up. Good job. Are we in frame?
We are in frame.
All right.
Good job.
Our master cinematographer.
Thank you.
You are welcome.
Can you reiterate that this is shaving cream and not whipped cream?
Shaving cream, not whipped cream. Why? Because we don't eat slime. Don't eat the slime. This is shaving cream. I don't know if whipped cream would work. I would never try it, because even if it did the same thing that our shaving cream's about to, it would make your slime really sticky because it's full of sugar. So shaving cream. Now look, we have a lot more material to start with than we did in either of our other previous slimes. But remember, the majority of this is shaving cream, and shaving cream is a foam. That means a lot of what this is itty-bitty, teeny-weeny little air bubbles. Like I said, it's not going to change the underlying chemistry of our slime reaction when we add our cross-linker. I'm going to do the starch again this time. It will, however, drastically change the kind of slime we end up with. because as the foam holds on to tiny air bubbles, it also allows the slime to hold on to those air bubbles as well. And we get ourselves a big batch of poofy slime. Can I get a little bit more starch, please? Much obliged, hands. Appreciate it. Okay, here we go. Got our foamy, fluffy slime mixed up. Remember, just like previous batches, if it's still really sticky on the sides of the bowl and on your spoon, it's not quite there yet. You need to add a little bit more of your own cross-linking solution, whichever one you prefer. All right, look at that. It's really coming together. Okay, so I'm going to do a little bit more kneading here with my spoon. Set it aside and demonstrate fluffy slime. There we go. Same chemical reaction. We just added something to hold some air bubbles into our slime. Pretty cool. All right. Hands, you can take those, please. I'm going to dry my hands off a little bit. For our very last slime, we're going to do something extra special. Hands, please bring me a bowl, a spoon, some plain white glue. There we go. We got that, we got that. I got food coloring. And if you could bring me that highlighter that I prepared earlier. Thank you very much. Here's the secret ingredient in our fourth, technically fifth and final slime. We're going to make glowing slime. To do that, we need ink from a highlighter. And you will notice that I very carefully removed the top of this highlighter so I can pull out the tube full of ink. This is something you will want your parents to do. You will want them to wear some form of safety glasses. They don't have to be fancy like mine. They can just be regular clear shot glasses, because if they're not careful, or, well, it could be totally careful, and they could still potentially end up with pieces of plastic flying through the air, you're going to want to be in a separate room. All they have to do is take just a regular old kitchen knife, try to cut this off as smooth as they can, and remove this tube full of ink. Got it? All right. That's going to be our key ingredient. In order to add the property of glowing to our slime, we need to add something that glows. And highlighter ink is also known as fluorescent ink. You may have heard highlighters referred to as fluorescent markers. That's because they have a property called fluorescence. Fluorescence, another way to think about it is, it's kind of, sort of, but not really, the opposite of glow in the dark. We call it day glow. Fluorescent things fluoresce. They give off light when light is already shining on them. And you usually can't tell the fluorescence of, say, a fluorescent marker during the day or with the lights on like we have in Science Port here today, because there's so much extra light. The light that these are giving off, as they absorb light and then give some more off, isn't really visible. But you always know something that's neon or fluorescent because it doesn't look quite like a normal yellow. That is how you can tell something is fluorescent. So I'm going to do fluorescent. Let's do yellow. You know what? Let's do some yellow. Do some fluorescent yellow slime. And then we will turn off the lights. So you want to do just like before. Just a few drops of food coloring, but then you, hands, could you please come hold the bowl this time? You really want to get ink, a lot of ink out of this thing. The more ink you're able to squeeze out of your tube, the more fluorescent your slime is going to be. So just milk it like a cow, I guess. Just squeeze it, fold it. We got a bunch of yellow stuff in there. You're going to get it on your hands. That's okay. All it's going to do is make your hands glow. That's it. That's all that's going to happen. All right, here we go. Now we start mixing up our yellow food coloring. No, it looks orange. Trust me, it's yellow. Our yellow ink and our glue. Now this ink, or anything that's technically neon or fluorescent, does something really cool at the level of atoms. So remember we were talking about atoms before, the itty-bitty teeny-weeny little pieces that make up all of the matter in the universe. Well, you can combine them into things called molecules, just multiple atoms combined into one single piece. But some atoms and some molecules are able to absorb a little bit of light and then release it back into the environment with just a little bit less energy than it had when it came to them. That's called fluorescence. The atoms, if we really want to dig into them, are also made of even tinier pieces called subatomic particles. And the three primary ones are protons, neutrons, and electrons. Protons and neutrons, they exist inside the middle, the center of each atom called a nucleus, and orbiting around them are these tiny little pieces called electrons. And those electrons exist in what we call energy shells, different levels that are closer to or further away from the nucleus depending on how much energy they have. When we get down into the level of subatomic stuff, it gets really, really weird. And when you add energy into fluorescent atoms, the electrons absorb that energy and they jump up to a new energy level. Here's the weird thing. They don't actually cover the space in between it. We call it a quantum leap. They just cease to exist at a lower energy level and suddenly appear at a higher one. But they can't last there for very long. They have to eventually release the energy that they absorbed from visible light and bounce back down to what we call their ground state, their original energy level. And when they do that, they give off slightly less energy than they took in because they had to use some of the energy up to get away from their ground state in the first place. And when they release that light, it fluoresces out from the atoms and can be seen as glowing. What we're going to do today with our fluorescent slime, you can tell it looks neon-y, right? You can see maybe it's a little bit fluorescent, but what we really want to do is see it in its true element. And to do that, we need a special kind of flashlight. You can buy one of these on Amazon, you can find them at Walmart. They cost at most $10. This gives off a kind of light called ultraviolet light, UV. Humans cannot see ultraviolet light. You can see there's a little bit of purple light, so there's a little bit of visible light mixed in with this. Ultraviolet light has a ton of extra energy compared to regular visible light. So when you shine ultraviolet light on something that's fluorescent, go ahead and turn the lights out. There we go. The lower energy light that leaves those electrons is visible to us when the UV itself was not. So let me get this out of the bowl so we can see some truly fascinating glowing Ghostbusters slime.
Hands can take the light and then you can.
Oh yeah, good idea. Hands. Here, let me get the rest of it out of there. That's why I have a lab assistant. There we go.
Never underestimate the power of a lab assistant.
There we go. So, glue, your cross-linker of choice, food coloring, and fluorescent ink from a highlighter. And we have glowing slime. Okay. Oh, that's really good stuff. I like it. I'm really happy with the glowing slime. All right. Can we get the lights back on, please? Thank you. Now here, I have demonstrated 4 and mentioned 5 different slime recipes. But as I said earlier on in this video, half the fun of slime making is experimentation, trying out different ingredients in different amounts. And that's what I urge you to do next. You know the basics of slime making. You need a cross-linker. You need some of this, or some of these. You need some glue, some of this. Or, you know what? If you can get your hands on something called PVA, polyvinyl alcohol, it's a kind of plastic that you can dissolve in water, and then you can use that with a cross-linker to make a totally different kind of slime. It's just a little bit harder to find than glue, so we didn't really talk about it. Different monomers set up into a different polymer give you a slime that has a completely different consistency than any of the slimes we had made here today. But what can you do with this? Maybe you can make glowing poofy slime. Maybe you can, I don't know, get an essential oil, put a couple of drops into your slime and make some delicious smelling peppermint green slime. Whatever it is you want to do, try mixing in different ingredients and experimenting and keeping track of your results. Because, look, science is great. What I do every day of my life is tell people how cool science is and teach them about science. But the real heart of science is experimentation, curiosity, and learning. And if all you ever do is sit at home and make the slime recipes that I told you about or that you read about somewhere else online, you're not doing as good a science as you could. So get out there, make some slime, and get creative with it. Cool? Oh yeah, and don't eat it. Remember, please don't eat the slime. It's a bad idea. All right.
Noted.
Yeah.
Thank you, Don.
You're welcome. Thank you.
Signing off.
All right.